Welcome to this explainer. Let's get right into it. You know that constant struggle we see in almost every modern workplace? Department silos. We're always talking about breaking down these invisible walls between, say, engineering, sales, and IT. And usually we point the finger at corporate culture, or bad management, or maybe just a serious lack of caffeine. But what if we've been diagnosing this entirely wrong? What if the root cause of these fragmented, completely distrustful departments actually starts long, long before we ever set foot in the office? Today, we're unpacking a really fascinating framework that suggests our workplace silos are actually a structural byproduct of how our national education system is built. It's kind of an uncomfortable question to ask, right? Does our education system literally manufacture the departmental silos that plague our organizations later on? Well, based on John M. Cachet's work, the source material we're digging into today gives a resounding yes. Think about it. Do engineering grads need to understand business? Absolutely. Does the business team need to understand IT? For sure. But as it stands, they're taught in total isolation. We're going to see why interprofessional, cross-functional exposure is the exact structural fix we need, and we'll look at the specific tools to make it a reality. So here's our roadmap for today. We'll start with the origin of silos, move into the white space problem, and then introduce IPE as the operating system. From there, we'll look at visualizing the handoffs with SIPOC, engineering success together with SME, and finally, rewiring national education. Let's jump in. Starting with Section 1, the origin of silos. To really understand the modern workplace, we have to look back at how we organize learning in the first place. Picture the traditional corporate management structure for a second. You've got sales, engineering, and finance, right? Now look at the academic world, business, IT, and engineering. The overlap is honestly uncanny. The reality is most national educational systems are still organizing degrees, accreditation, and even their physical campus buildings around these 19th and 20th century boundaries. We're talking separate faculties, totally different grading rubrics, and practically zero shared vocabulary. Because students specialize so early and are graded completely within their own little bubble, there's just no institutional incentive for them to build cross-disciplinary fluency before hitting the workforce. But as we all know, out in the real world, massive projects like a digital transformation, they don't care about those boundaries at all. Which brings us to Section 2, the white space problem. Now, the issue here isn't specialization itself. I mean, we need specialists. The real danger actually lives in the gaps between those specialists. This is what we call the white space. Think of this white space as having actual physical weight. It's the unowned connective tissue or the handoffs between different functions where inefficiency and rework just thrive. In a corporate setting, this is sales promising a feature that engineering literally cannot build on the timeline finance just approved. In education, it's an engineering grad who is a genius at design but completely freezes when they have to translate a design trade-off into a cost argument for the business team. Or a business grad greenlighting an IT roadmap without the technical literacy to even evaluate it. These aren't just knowledge gaps inside a single department, they're gaps in the handoffs. And right now, traditional curricula assign absolutely no one to own them. Moving to Section 3, IPE, the operating system. So how do we actually fix this? Spoiler alert, not with another catchy leadership slogan. We fix it with a concrete mechanism. Enter Integrated Process Excellence, or IPE. This was developed by John M. Cachet, building on Roger Slater's deployment model from the 90s. An IPE isn't just some aspirational training seminar. It's a full-on operating system for management that unites people, process, and technology. It runs on 6 universal steps. You create a positive environment, identify key variables, develop process worksheets, communicate those worksheets, control the process, and finally, improve it. Basically, it takes cross-functional collaboration from a nice idea and turns it into a highly measurable, governed system. But what's truly a game changer here is IPEL's underlying philosophy, process orientation over functions. This is your ultimate cure for silos. Instead of looking at a traditional org chart to see who owns what task, protecting those departmental fiefdoms, you remap the entire organization based on how value actually flows. From the customer's very first need, all the way through design, creation, and support, it's treated as one continuous chain. If you apply that to a university, engineering, business, and IT are no longer 3 separate destinations. They are 3 sequential stages of a single value stream that a student moves through. That takes us to Section 4, SIPOC, visualizing the handoffs. To make this value stream actually work, we need a tool to define those handoffs. And that tool is SIPOC, which stands for Suppliers, Inputs, Process, Outputs, and Customers. This is embedded right into eyepiece, and it forces every single process to explicitly name who supplies its inputs and who consumes its outputs. It takes all that hidden tribal knowledge and turns it into documented fact. So, for example, a SIPOC mapping for a degree might name IT as the supplier of data architecture skills to the engineering program, which is acting as the customer. The beauty of this is that once it's written down, these aren't three unrelated boxes anymore. They become stages that literally owe each other an inspectable, measurable output. The handoff is finally visible.
Next up, Section 5, SMEA, Engineering Success Together. Okay, so now that we can see the handoffs, how do we guarantee they don't drop the ball?
You might already be familiar with FMEA, Failure Mode and Effects Analysis. It's a reactive tool where a team sits around and lists absolutely everything that could possibly go wrong. Well, SMEA, Success Mode and Effects Analysis, completely flips the script, and it is brilliant. SMEA is totally proactive. Instead of starting from failure, it starts with the exact outcome you want to achieve, and then asks, okay, what conditions must be present for this success to happen? By definition, this requires every single function that touches the outcome to be in the same room. Engineering, business, and IT faculty can't just sit in isolation and guess what makes a successful graduate. SMEA forces them to jointly agree on what success actually looks like, together. The really crucial takeaway here is how these three artifacts interlock. If you take even one away, the whole fix just collapses. IPE provides the governance layer, the actual authority to run process ownership permanently. SIPOC supplies the definition layer, that shared map making all the dependencies visible. And SMEA delivers the accountability layer, the forcing function that makes joint success planning happen. When you put them together, they take that vague corporate slogan of break down silos and turn it into concrete, repeatable artifacts.
And finally, Section 6, Rewiring National Education. Let's bring this whole narrative full circle.
Let's apply these exact enterprise tools back to where the silo problem actually started, our education model. Doing this takes 4 concrete moves. First, we build one single SIPOC map of the student value stream. That means mapping their entire path through higher ed and into the workforce as one unbroken chain. Second, we take IPE steps and turn them into joint process worksheets. Think shared rubrics and capstone projects that are co-owned by multiple departments. Third, we run SMEA during the accreditation cycle. We evaluate the handoffs and those cross-functional outcomes rather than just grading departments in a vacuum. And fourth, we govern by process performance. We should be tracking, say, the percentage of engineering students who complete a business context requirement, not just how well the engineering department is doing on its own. Now, there is one absolutely critical caveat to all this. Inside a regular enterprise, IAP works because every function shares the exact same endpoint, the customer. For the education system to actually rewire itself, it has to define its customer as the labor market and employer outcomes. Engineering, business, and IT requirements have to be backmapped from that shared endpoint. Because honestly, without defining the labor market as the shared customer, your SIPOC map has absolutely no direction, and your SMEA exercise has nothing to plan toward.
So we've seen how silos aren't just some accident. They're a structural byproduct of organizing learning by function instead of by a continuous value stream. But by using IPE to govern, SIPOC to define, and SMEA to plan for shared success, we can replace those isolated pipelines with one truly accountable value stream. I want to leave you with this to chew on. Does your organization, or even your alma mater, actually measure cross-functional success? Or are they still just grading department performance in the dark? Think about how these tools could completely restructure your own environment. Thanks for joining me on this explainer. Keep learning, and we'll see you next time.